Hey YouTube, I'm Mars1952, and I've been getting a lot of grief lately about how I'm running up the electric bill and melting the glaciers by leaving my cell phone chargers and things like that plugged in. So I always thought that these things didn't use much juice, but people have been arguing with me about that and saying that they use a whole bunch of electricity and a lot of it's going to waste. Parasitic load, I think they call it. So I want to test that. So I'm using the tools I have at hand. I'm going to give it my best shot. I've got a kilowatt meter here that should show up in the upper corner, and I've got 6 outlet strips all tied together into one that goes over to the back of the kilowatt meter. Kilowatt meter is plugged into the power, so all this is powered by juice running through the kilowatt meter. Now people have argued that the kilowatt meter and things like that aren't accurate enough to get the reading off of something like this. So let's give it a try and see what happens. So this one and a whole bunch of other ones that I have show 0 on that meter when you plug it into it. Now these draw 2 watts. Now it'll show 2 watts. I'll get this in there. Well, it's actually showing 3 on that one. Now I have a couple other things to test. This is a 7-watt LED light bulb. Let's plug it in this one for variety. And it is showing 8 watts. This one is a 15-watt refrigerator bulb. That's going back and forth between 14 and 15. So this one is a 40-watt light bulb. Must be a 60-watt. That's a 60-watt. Let me look at that again. Yep, 60-watt light bulb. So it just doesn't like to read anything below 1 watt. So to get over that, we're going to plug in a whole bunch of these and see how much power it draws. So I've already put a bunch of these together. Everything in this top basket here does not show any watts when I try to plug it in. So let's get these plugged in here. I might have to cut some of this out. I'll show you the main things. Alright, so to test exactly how much power you're drawing out of these little ones that don't show any power draw when you plug them in, I'll do a bunch of them. I'm going to plug as many as I can into these 5 outlet strips, or actually 6 outlet strips, and see how many watts we're drawing. Let me zoom in so you can get a little bit better view. So I've already plugged them into adapters. Normally you're not supposed to daisy chain all kinds of stuff like this together because you can draw too much current. But in this case we're only going to draw a few watts, so it doesn't really matter. Let's start plugging these in. And you can watch the kilowatt meter. So those 3 combined, it looks like they're drawing a watt. Here's some more. Plug this in here. Not quite a watt out of those 3. These are DSL power supplies. Of course they would be on all the time running stuff. Not much out of that one. Couple Motorola power supplies, so the older ones for cell phones. Couple more cell phone chargers. Alright, so that one, need to move this down one. Make room for this one. Hope that doesn't go there. Make sure they turn that off. This is going to be quite a mess once I get these all plugged in. What do we have going? 3 watts so far. Those aren't spaced right. Well, that's not going to work. We're all the way up to 5 watts. Not going to fit. Another one. Right, that's all the chargers I have that only drew less than 1 watt. So, how many do we have plugged in here? Make sure I didn't miss any. Okay, so back up a little bit. Alright, so we're drawing 7 watts now, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 13, 14, 16, 18, 20, 22, 24, 26. Okay, 26 power supplies that draw 7 watts each. So, what does that make that? Oh, no, not 7 watts each, 7 watts total. I've got 26 power supplies plugged in here, and they are drawing 7 watts. So I'll do a calculation and put that up here. Alright, so now I'm going to switch over to these other ones. This type of charger. These are all smart chargers. They're fairly new. They sense when the battery needs charge, and they add to it. When it doesn't need anything, it doesn't do much. Now this type of charger, this is a big heavy transformer. This is the old school type of charger, and you plug these in and leave them, they'll actually get hot. So these are going to be drawing more watts. I'm going to pause it and undo all this stuff. So now let's plug in some of these old school chargers. These chargers here are smart chargers by Makita, but they draw 2 watts each just when they're sitting around. It's showing 3 there. It's a hungry one. so we have 5 plugged in. It's drawing 14 watts today. Last time I did that they were only drawing 2. So 14 watts. Now let's plug a bunch of stuff in and see what happens. Start off with the monster charger here. They'll draw a little bit and then come back, so it's only drawing 2 watts. These things take up a lot of room on the charger, so we got up 18 watts. A lot of room on the outlet strip is what I'm trying to say. I don't have as many of these as I do of the newer ones. It's a big old clunker. Alright, do we have any left over? These are the modern ones. Modern. Well, that's enough. We're drawing 34 watts. How many do we have here? We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. So we have 23 chargers. They're drawing 34 watts. It's still less than 2 watts per charger. So what it boils down to is, well, let me say something first. Now, we pay 11 cents a kilowatt hour here for electricity. So that means a 100-watt bulb that you plug in and leave on 24/7 will use about $8 of electricity in a month. So 10 watts uses 80 cents. So we got 34 watts. So that's $2.40 plus 40 cents, about $2.80, rounded just roughly, for, I lost track of how many chargers I have here. For all these chargers, it's unlikely that you're going to have this many of the old type chargers. I've once again forgotten already what the first one is. I'm going to have to figure that out and when I look at the videos. But you're not going to save a lot of money, is what I'm trying to say. You're not going to save a lot of money by unplugging these every time you're in between uses. But multiply this out by several billion across the planet, and that works out to quite a bit of watts. So what does this all mean? What it means to me is if you have a charger like this one, it's drawing, I don't know, I have to go back and figure out how much it actually was drawn, something less than a watt, it's not going to affect your electric bill at all, even if you have 10 of them plugged in. 10 of them only cost you 80 cents a month at the most. But multiply that out times billions across the planet. Who knows how many billion chargers there are. We have around this house probably 10 or so in use all the time, maybe even 20. That adds up to a lot of electricity. If it's not being used, that's just going to waste. These older type of chargers, they waste even more. So what I do is, if I'm using my cell phone charger, I use this almost every day. I just leave that plugged in, and I plug my cell phone in when I need to. So, but this type of stuff, some of these things I don't use very often, it's probably best to unplug them when I'm not using them. It's probably best to unplug them when I'm not using them. That way I'm not wasting electricity. Even if I left all these plugged in, it's not going to break my budget. It's only a couple bucks a month. So anyway, I don't think it's melting any glaciers. That's all for today.